Hello everyone. In today's session, we'll be discussing a topic from Module 4 Underwater Chemistry, that is priming and foaming. The outcome of the discussion could be listed as follows. The students after the discussion would be able to define the terms priming and foaming, explain the different causes, list some disadvantages associated with the process, also quote some overcoming measures. Now before going for priming, let me give quick glance of the previous session. In the last session we had seen what is boiler feed water and if the boiler feed water contains any impurities, what are the different possible problems that are created with the boiler. First one was formation of scale and sludge in the boiler body. So the second one listed was priming and foaming. Now let us see the second boiler problem in detail in this particular session. So here sometimes in the boiler it so happens a rapid boiling may takes place inside the boiler, and here the steam so produced would carry some water droplets, and actually any boiler when produce steam we expect it to be a dry steam, and whenever steam carries water droplet we call that particular as wet steam. There is also possibility that the wet steam may be associated with some salts, that is impurities present in the water. So the process of wet steam production in the boiler is called as priming. So what to be remembered here is, in this particular slide is, most of the time due to uneven boiling or rapid boiling of water, the steam produced would be carrying some water droplets along with some salts. This particular steam is called as wet steam, and production of wet steam is called as priming process. Now let us see why priming takes place inside the boiler. Okay, it needs little bit imagination why the process happens. Now let us imagine this is the boiler body, okay, this way, which is having some pipeline connection to the external source, and here this is connected to a system where large amount of gadgets may be connected. It's been said that whenever in an industry associated with the boiler, a large piece of the equipment start working all of a sudden. Imagine suddenly an apparatus which is fitted here start undergoing working. Automatically what it would do, this particular instrument may require some steam which is drawn from the pipelines. Okay, immediate vicinity it is connected to the pipeline, so steam produced here might be drawn to the system from the pipeline. Automatically in this area, that I mean the area of the pipeline, the pressure would be decreased. So what is the natural tendency now? The steam produced from the boiler must go to the pipeline, so net pressure inside the boiler would decrease. This decrease in the pressure in the boiler would actually make the rapid or uneven boiling to takes place. In the sense, it actually tries to compensate its speed of production of steam, so it would be undergoing the process of rapid boiling. Now let us see how we can state it as sentences. So here, whenever a large piece of equipment start working, the steam from the pipelines would be extracted. Now what must happen? The steam from the boiler should surge, or it must rush into the pipelines so as to have a uniform distribution. This automatically would lower the pressure inside the boiler, and that is going to cause the priming process. Okay, in this, the first diagram what we are seeing here is actually showing the schematic representation or cross-sectional view of a boiler. So here this area accounts to the steam generation area, where the droplets of the water along with the salt present are carried away, and we call that particular process as priming. Now this particular diagram actually tells the science behind the priming. So this is any other normal boiler functioning where water is there, steam is produced, it is moving via the pipelines. And what happens whenever there is a sudden demand of the steam? this particular area, that is this area, would be having decreased pressure. So in order to compensate, from here water would boil very sharply, very fast, at faster rate, and steam would be produced, which is nothing but a case like this. That is a bottle filled with the liquid, maintained at very high pressure. When the lid is open, suddenly how it rushes outside, that particular phenomenon would be observed with the boiler. Now let us list some other reasons of priming, or simple way how we can quote the reasons of priming. So first and foremost may be the designing of the boiler. Improper designing of the boiler may lead to priming. Second thing is taking very excess level of water. Third one is high velocity steam formation. Fourth one, as we said, uneven or sudden boiling of water. And fourth one is also quoted, that is impurities present in the boiler feed water. Now let us list some disadvantages or learn some disadvantages about the priming. Okay, so here what to be remembered is, as the steam carry the water droplet, the heating ability of the steam would be reduced. In the sense, efficiency of the steam would be decreasing. Then the salt which is carried may deposit on the parts of the boiler, that is specifically the turbine blades, and may cause the corrosion of the metal present there. Then if at all we leave it there only, that means it is not removed by means, then it would reduce the lifespan of the engine. So priming may carry the steam, so that the wet steam would be having lesser efficiency than dry steam as far as its heating ability is concerned. Also the wet steam may carry the salts, and these salts, if deposits on the engine part, they would cause the corrosion. And if dissolved salts are left as such without removal, they would be reducing the lifespan of the engine. Now let us see some controlling measures. So simplest possible I have quoted here. First and foremost, as we have seen, improper designing lead to priming formation. So first is proper designing of the boiler, that is from the manufacturing end. Second is, we know that excess water level may cause the priming to happen. So we'll go for an optimum level of water. Specifically speaking, little bit low level is more favored compared to high level of water, that is maintaining proper water level. Then go for proper boiling rate. Uneven boiling must be avoided. Also go for softening of water, because we know that hard water would contain some salt and can cause the boiler problem. So if we go for softening of water, good quality of water is used, means problem could be minimized. Then by blowing of the scale and sludge. Sometimes the scale and sludge present would be adhering themselves onto the walls of the boiler, may increase the wet steam production. So if you remove that scale and sludge, indirectly priming could be eliminated. Then this is mechanical approach, where you fit a mechanical purifier for the steam. That is, actually steam would be going out as a wet steam, but while going out only, you will apply a mechanical purifier, and only dry steam is allowed to move ahead. Let us now see another important boiler problem, that is called as foaming. Foaming word must be very familiar, because it is nothing but formation of a froth on the surface. So here also in the same context, foaming is used. Now how to define the process foaming is, that is the production of small but persistent bubbles on the surface of the boiler. Actually froth formation is also same. In the same context we use the word foaming. We can now ask the question, why foam is produced in the boiler feed water? The reason is the lubricating oil which we use. In fact, for the functioning of the boiler, to have smooth functioning, the lubricating oil usage is a must. And whenever these oil come in contact with the boiler feed water, the process of foaming would be taking place. So let us define foaming. Foaming is the process of production of small but persistent bubbles. And these pictures actually shows how foaming would be taking place. It is to the large extent in the boiler. Continuous froth formation would be taking place on the upper surface, and this is a normal operation of a boiler, and this is the foam formation status. And analogy is given. So we take a bottle where we take water beneath, and soap or soapy action or foam is filled here, and we take a straw and we blow. What condition would happen? Same would be happening at the surface of the boiler. Now let us see in detail the chemical reason behind the foaming. So first and foremost, it is, I said, the oil or the greasy substances present cause the foaming to happen. How exactly it happens is, suppose any oil droplet is there and an alkali kind of salt is present, they would be reacting with each other to give a soap. This is a known concept. Oil and alkali react to form soap. And what is the nature of soap? It always lowers the surface tension of the water. And whenever surface tension is decreased, automatically the foam formation would increase. So one reason is presence of oil which reacts with the alkali to form soap, and soap would be forming froth on the surface of the water. Second reason could be difference in the concentration of salts. How? Between the surface and bulk. That is, if we see boiler as a whole like this, the bottom portion would be having some concentration of salt, top portion would be having another concentration. Because of this difference in the concentration of the dissolved salt, again viscosity would increase. Viscosity of the water would be increasing where the surface layer, and thereby there is a change in the property of the water, and more froth or foam formation would be taking place. Let us once summarize the reasons. One is presence of oil causing the soap formation and froth. Also another is presence of dissolved impurities which changes the viscosity of the surface layer. Now let us see the disadvantages with the foaming. So here this concept is actually studied. Whenever we defined scale, we said that the bubbles from the surface of the water would strike the boiler wall and leave salt there, and that salt would become scale. So that is one of the prime disadvantage of foaming. The rupture of the bubble would deposit salts on the boiler causing scale. We can simply write that foaming actually forms the scales on the surface of the boiler. Then it is actually very difficult to maintain the boiler pressure. Whenever large amount of bubbles are formed, the pressure inside the boiler would be varying. This will increase the wet steam production. Actually, foaming indirectly now is the reason for scale formation as well as priming process. Foaming indirectly causes scale, indirectly causes the priming to happen, as well as wastage of fuels would be taking place because boiling rate is changed. So let us once summarize the disadvantages of foaming. That is, first one is rupture of bubbles causing scale, then boiler pressure disturbed, then wet steam production is favored, and wastage of the fuels would be taking place. Let us see some controlling measures. So here this is easy to understand. We will add some anti-foaming agents. Since foam is formed, add a counter chemical so that bubbles would be bursted and further bubble formation will not take place. Best used is anti-foaming agent is castor oil. This is actually used to reduce the surface tension of the water, and hence foaming could be avoided. Another approach is removal of the oil. That is, we know that oil creates foaming, so remove the oil from the water surface. And this word must be familiar. Here we add coagulants. Coagulants means they will be combining with the oil and they will be making the another product and that precipitates. So here best used coagulant is given. One can go for aluminium sulfate or sodium aluminate, or else you can simply write some derivatives of aluminium could be added. What happens, this aluminium derivative would be reacting with the oil and further undergoes hydrolysis to give the aluminium hydroxide, which would be undergoing precipitation, so filtered and removed. So here two controlling measures are adopted. One is usage of anti-foaming agent, another is removal of the foaming agent, that is oil. Let us now once quickly go through all the slides whichever we have discussed so far, and let me tell the important point for exam point of view. So here in priming, definition of wet steam and priming is important. That is, the water droplets carried with the steam along with the associated salt is wet steam. Process of wet steam production is priming. Then you can directly go to the slide number 7, where reasons of priming are listed in brief. That is, improper designing of boiler, high water level or velocity variation, then sudden or uneven boiling and impurities present. Disadvantages must be known, and any two controlling measures, if possible 4. Then definition of foaming, that is production of small but persistent bubbles. And then reason of foaming, you can write little bit brief. Here I have elaborately explained so that understanding takes place to the fullest extent. Then disadvantages of the foaming along with the mentioned two controlling measures. So in the next session we would be discussing about the third major boiler problem, that is boiler corrosion. Thank you.